Hi, welcome to my channel. Today we are going to see wave motion. Okay, till now we have seen that concepts related to the mechanics. Now we will start with wave motion or indirectly analogy of wave. How these waves are producing. So in this session we are going to see that how the waves are producing, and next what is the definition of waves, what they will do in the nature, how it is important to us, and next concept is what type of waves that we are having and how to define that waves, how mathematics helps to understand the waves, that means mathematics related to the waves, how to create the waves, and what parameters explains about the waves. We will see these all those things here. And then sound waves, especially we will concentrate on sound waves, and then light. Anyway, we will see it light later. So we have a different unit called as optics. So anyway, this is a branch of wave. So first we'll start with the definition of wave. For example, if you are transferring energy from, anyway energy will transfer from higher energy state to the lower energy state. So if you are transferring energy, if you are making a disturbance in the medium, so the medium is anything, might be air or something, indirectly that you are disturbing means you are losing some energy. That energy will be transferred from that position to the other position in the form of a disturbance. So we call this disturbance as wave. So wave is simply says that the disturbance created in the medium. So that means indirectly the energy is transferring from one point to the other point. So this is called wave. So we have different types of waves. So depending on we have so many classifications are there. So depending on the medium classification, we can done that classification depending on the medium. So the first classification is depending on the medium. So depending on the medium, the waves are divided into the two types. One is mechanical waves and non-mechanical waves. Okay, so mechanical waves. In mechanical waves, we generally says that this one is classified by depending on the medium. That means if medium presents, if the wave is traveling in that medium, we will say that wave is called mechanical wave. Indirectly says that if there is a medium is disturbing, the energy is transferring from one point to the other point, we say this type of waves are called mechanical waves, because they need a medium like air, liquid, anyway anything, solid or something. So we say these all the things that comes under the mechanical waves. Non-mechanical waves we say simply without medium. For example, vacuum. If that waves are traveling in vacuum, then anyway we'll see these things, how these energy is transferring without medium. We'll see these things when we discuss about the light. So we should stick to the mechanical waves. In mechanical waves, the energy will transfer from one point to other point by the disturbance. We call these type of waves are called mechanical waves, because here the disturbance is done due to the particles of the medium. So we'll see that how the energy will transfer from one point to other point. The disturbed particle interacts with the neighboring particle and its energy is handed over to the next particle due to the inertia. For example, if you are considering at this position, the particle is transferring to the neighboring position particle, and then it is hitting that particle due to the inertia. Again it will come back to the initial position due to the elastic property of the medium, because initially start from here, because of the over energy it is displacing from one location to the other location, and it's hitting and it is transferring energy to the other particle, and again it is coming back due to the elastic property. So we say that in mechanical waves generally present in the medium, if and only if that medium is having two properties. One is inertia, anyway all mass particles will have inertia, and second one elasticity. Okay, without that elasticity it's not possible to transfer the mechanical wave from one point to the other point. This is one type of classification. And the second classification is Second classification is uh, it's like it depends on the mode of propagation. So we'll create into the one dimensional waves, two dimensional waves, three dimensional waves. So one dimensional waves, normally we say these things are um, these things will easily found in a stretched string. If you take a string, just disturb it, then automatically it will do some oscillations. It is making some disturbance. So the disturbance is moving either in this direction or in this direction. So this is the one dimensional wave. Two dimensional wave. If you take a pound of water, the disturbance will travel like this. If you disturb at this position, so this disturbance is in that plane. So we say this one is a 2D. Three dimensional. For example, if you take a light, it's like a light energy. It is transferring to the space from a point source. If we consider a point source, then light energy will comes out as a spherical shells. The bulb, the whole energy is coming out throughout that bulb, enter that space present in the bulb. So that is three dimensional. That is out. It's covering some volume. We can simply say that there is three dimensional. Or else your voice also. Your voice will reach in front, back, up, top, and everywhere. So in all directions it is going. So we say this one is in three dimensional waves. So this is depending on the mode of propagation. We divide into the waves into three types: one dimensional, two dimensional, and three dimensional. Now next one is classification depending on the vibration of particles in the medium. So how they are vibrating while wave is moving. For example, if you concentrate on these things, you have already seen these names. One is longitudinal wave, next transverse wave. So we'll concentrate on the longitudinal wave. That is so simple. For example, you are talking, that means here is a loudspeaker is present. So if the loudspeaker is making this disturbance, then automatically the disturbance will travel in this way. So that means we are making the disturbance, so the wave is moving in this direction. At the same time, particles displacement also in the same direction. So if the particles movement is parallel to the vibration direction or wave propagation is nothing but movement of the wave propagation, we say that type of wave is called longitudinal wave. What is happening in the longitudinal wave? Simple. The disturbance created by the speaker is traveling in this direction. At the same time, air particles also will displace in the same direction. Anyway, they will come back due to the inertia. They will come back due to the elasticity property. But waves movement is parallel to that particles movement. We say that type of wave is called longitudinal wave. And second one is transverse wave. Transverse wave is nothing but, for example, if you take a rope, just tie it at one side and then pick up at this position and then just give an impulse in upward direction and downward direction. And what will happen? It will create some waves like this. Here you are doing upward direction, means each particle on the rope will tries to go up in the direction till this point, because you are moving in upward direction, so the particles are going up. After this situation, you are bringing that rope to downward direction, so that means each and every particle will tries to come down. So from this concept you can see that all particles are going up or either they are coming down due to the direction of your impulse, but the disturbance is traveling in this direction. So if you see that the disturbance is traveling in this direction, either particles are going up and coming down. So we see this thing here 90 degrees is present. So from this concept we can say that the propagation of the wave is perpendicular to the particles movement. So we say this type of waves are called transverse waves. So this is the third type of classification. Anyway, depending on the mode of vibration, we said that only two types of waves are present. One is longitudinal wave and transverse wave, but we have other types of waves also. Some waves are not purely transverse or longitudinal. We call these things as seismic waves or earthquake waves produced in the inside the earth. They will travel both in all the directions like longitudinal and transverse waves. So such waves have complex in nature. Indirectly we can see the tidal waves in sea are another example for that complex waves. Okay, so we'll go for the next type waves. Okay, so this one, the classification of mechanical waves based on transfer of energy. So this transfer of energy, we have two types of waves. One is standing waves or simply stationary waves. We call these two things are same, stationary waves or standing waves. Next one is progressive wave. Progressive wave. So we are concentrating on standing waves. Standing waves are those waves which remain confined to a region without any transfer of energy and momentum to the outside. So those type of waves we call this one as standing waves. That means if you are making a disturbance in the rope, the wave will go and then they will hit at this position, again that wave will come back. That means the energy is not going away from this wave, the energy is always be in the wave itself. So these type of waves we call this one as stationary waves. Next, progressive wave. This progressive wave is like it will go to the infinitive. That means it is transferring from one region to the other region. Anyway, it will transfer the energy from one region to the other region. For example, we are shouting on the pound of water. This is water. So we are shouting at this position. The energy is disturbing is creating like this. The sound energy will go inside this. So this type of waves we call this one as a progressive waves. So from now onwards we will concentrate on the progressive waves. We will understand how to represent the wave in mathematical form, and then how the standing waves will produce, and then we will understand the basic nature of standing waves, how the energy is transferring, how the energy is same in the standing waves. We will see all those things in this concept. Okay, we will concentrate on the mathematical representation of the wave. Anyway, just now we came to know that waves are three types by depending on the propagation of the wave. So one-dimensional, two-dimensional, three-dimensional, like this. So anyway, we will concentrate on one-dimensional because if you go for two-dimensional, three-dimensional, it will become too complex as per mathematics. So we will stick to the one-dimensional. So anyway, before going to this one, you need some mathematics. So for example, if you are writing y is equal to f of x, means that y value always depends on the x by following some function. Function is nothing but it can be anything. For example, if you write f of x is equal to x square, so that means whatever with x value is here, if you keep one value here, it will scale and it will give some value. That is called function. It is doing some work. What it is doing, it is just simply squaring the value that what you are giving in the place of x. So that value will be equal to the y. So in 10th class that you have already seen that how y is varying if x value is varying. So this is the meaning of that parabola that you have drawn in 10th standard. That means the x is varying by point to point, the y value is varying point to point. For example, if you consider x value here, you are getting a y value here. If you are getting x value here, y value here. So x is changing, y is varying. How that y is varying depending on the x that is given by the function. But here our function is not constant, because the disturbance, for example, if you take a pound of water, the water will goes up, it will goes down, it will goes up, it will goes down, and then it will reach the boundary. So this it is going up and it's going down, and then it is finally reaching that point at the end point. From this we can say that this function, whatever the function that we are considering, it is changing due to the distance. That means it is a physical distance x. This is from the center, it is a physical distance x. At the same time, as time passes, that wave is traveling from one point to other point. For example, if you take a snapshot, that means at a fixed time t, it will have some shape. That shape will change from point to point. This is x-axis. For example, this is a rope. Just I give a just a plug like this. Then automatically what will happen? There will be one string. Some disturbance will be produced. If I take the photo of that, it comes like this. So at that time, I am calling that time as t. So at that time, I am concentrating on this particle p. Some time t, I am concentrating on the one particle p. So it's at this location. So at this location, I am calling this location as zero location. That means this is a distance. Okay, at that some time t on my watch, I took the snapshot of this wave, that is x equal to 0. After some time what will happen, this wave disturbance will transfer to somewhere. So after some time this disturbance is travel to this much distance. If there is no loss of energy, then it will be, the shape will be looks like the same thing. So from this concept I can write the y value. What is y value? The shape of this curve. Okay, at some, after some time it is being looking like this. That means in intermediate between, for example, we are talking from this time to this t dash time, the shape of the graph will be, after some time it will be looking like this, after that it will be like this, after it will be like this. So that means it is traveling like this, and finally at this time we are considering. So we are considering at the two time slots. The first one initially is like this, after some time it became like this. So it is traveling on the x-axis. So I am taking this distance. Okay, so at this concept I am considering that y is equal to f is a function, it depends on the both time and displacement. I can write f is y is equal to f of x comma t. At this position I am keeping x equal to 0 because there is no displacement, even there is a y value is here. So I can write y is equal to f of 0 comma t, or simply I can write as a t. This function is not depending on x at the time. Okay, after this it travels some distance. For example, same particle, I am considering that p particle, it travel a distance x. So at that situation, the time of this slope, this shape, can be written in terms of some function y. That function will have, it depends on the time. I am considering this one as a 0 at this position, x dash is equal to 0, other function. That means I am shifting the same graph from here to here. By making that here x equal to 0, initially I considered, now it is became, it travels some x distance. Now I am keeping x dash here 0. At that time we will have a some other time, we need to calculate that time. So how much time it will take to travel from here to here? If you define the v, that is wave velocity, that means it took the velocity from to travel from here to here. So if you define this one, you can find the time to take travel this x distance. So how do you calculate? For example, if I write the time to travel from here to here, the t should be equal to, anyway velocity is equal to x by t. Okay, so then t can be written as x by v, velocity is equal to x by t. So this time is done. So if I bring the same shape to back, then automatically it will be coincide with this wave. How to bring this thing to back? Because some time gone, if I subtract that time, then automatically it will come back. So now the clock is showing this time. Initially at time t I have this shape. Now time became this time, that means it traveled some distance, it took some t time to travel from here to here. Now the time will increase by t plus t. If I subtract this time at this position, then automatically it will come back, right? So I can write that the time at that position has to be subtracted by the amount of time traveled, then it will come back to the initial position. Then I can equate these two values, or else I cannot. So fy is equal to f of t minus x by v. Now this function is depending on the x. Why? Because it travels some x distance. Understand? In the initial case at this position, it depends on only y is equal to f of t only. Why it is only t? The reason is at this position x equal to 0. But after some time it traveled to some distance, the distance is equal to x. If we take x, then we can say that we can write t value to bringing back to this side, and we are getting this function. So this is the mathematical equation of a wave. That wave is also traveling in this direction, that is positive x direction. That's why we are subtracting the time. If it is going back, then what we have to do? We have to add the time. Okay, that is negative direction. Okay, just wait, I will change the paper. After getting this equation, so we got that y is equal to f of t minus x by v. So this equation is, this y is depending on the both t and x. Now we are going to see that how to check that whether the given equation is wave or not. So it is so simple. So before that we have to create a, we have to derive one expression such that it will gives that value. So to do this one, I will do that just integration, sorry, LCM. I will get f of vt minus x by v anyway constant, then no need to bother about the function because it's simply scaling the function. Okay, you will understand if you know the mathematics correctly, or else it will be too difficult to understand this concept, because I will say that f of x is equal to x square. For example, if I write f of 2, then it will become 4. For example, if I write that x by 2, it will become x square by 4. So here x square, here x by 2, it will become x square by 4. But if you draw the graph, the shape will be the same. X square by 4 will be anyway y value that it will take some time. It will be like this. But anyway, it represents the same characteristics of the wave. It is scaling factor of the wave. So that is why I am neglecting this way. After doing LCM, v will be present, so I am neglecting it. Even if you wish, you can keep it also. So this is the equation of the wave. That wave is moving in along positive x direction. Okay, now after getting this value, we have to provide one general method to derive the equation, to check the given equation is representing the wave or not. To get that one, we have to differentiate the y 2 times partially with respect to the time. Similarly, we have to differentiate the equation of the y partially with respect to the x. Okay, so and then dou square y by dou t square. If you 2 times you have to do this thing, then you automatically will get a v square f double dash of vt minus x. Okay, next function is dou square y by dou x square. Then automatically you will get a, first time you will get 1 minus, again you will get a plus, so it will become f of vt minus x f double dash. If you see that dou square y by dou t square is equal to v square times of this value and this value both are equal, just keep here this equation, so you will get to a dou square y by dou t square is equal to v square times of dou square y by dou x square. So this is the general checking if the given equation is satisfying this equation. Automatically we can say that the given equation representing a wave equation, one dimensional wave equation. Why I have done these two things? Check it out from the reference book and learn the concept from the book. Thank you for watching the video.